So welcome to Unit 2, Analytic Geometry. Today we're going to be taking a look at graphing lines. And you've done work with graphing lines before, but we're going to review this. So your goal today is I can graph lines by making a table using slope and y-intercept and by finding the x and y intercepts. So we're going to start, method one is making a table of values. So here we've got an equation for a line. And when we do a table of values, we can choose any values we want for x. We substitute them in and then figure out what y is equal to. Whenever we have a fraction here, so here we've got a 3, you want to pick x values that are multiples of the denominator. So we want multiples of 3. So in my table, I'm going to choose -6, -3, 0, 3, and 6. Okay, those are all multiples of 3. 3 divides evenly into all those numbers. So now to figure out y, I'm going to substitute the x values that I've chosen into the equation where the x is. So if I'm going to substitute in -6 first, it's going to be -2/3 times -6 plus 5. So -2 times -6 is going to be +12. Divided by 3 is going to be 4. Plus 9, or plus 5 is going to be 9. So I get 9 for y. So my first point is going to be -6, 9. I do the same thing for the next one, so I substitute -3 in this time. And I do the same calculations. -2 times -3 is 6. Divided by 3 is 2. Plus 5 is 7. So -3, 7. We always love substituting in 0, because anything times 0 is 0. So 0 plus 5 is going to give us 5. And whenever we're graphing a line, the table of values will have a pattern to it. So as long as the x values have a pattern to them, the y values will have a pattern to them as well. So I know that over here I'm going to get 3 for this x and 6 for this x. So the x's are going up by 3 each time. The y's are going down by 2 each time. So my next y value, if I go down 2 more, is going to be at 3, and the last one's going to be at 1. All right, and then you can see we've already got the line on the graph here, but we'll just double check here. So at -6, 9, we've got that point there. So that's the first point there. We've got -3, 7. What's that point? We've got 0, 5. We've got 3, 3. And we've got 6, 1. Whenever we graph lines on a graph, we want to put arrowheads on the end to show that that pattern continues, so it keeps going. And then we want to write the equation of the line beside the line to so we know which line we've just graphed there. Okay, so that's table of values. This time we're going to graph the same line, but we're going to use the slope and the y-intercept. So important to remember that that's the formula for the equation of a line when it's in slope y-intercept form. So remember that m in this equation represents the slope, and the b on the end here represents the y-intercept. So from the equation that we have here, there's our m, and there's our b. So m is equal to -2/3, and that's my slope. And b is equal to 5, and that is my y-intercept. And then what I do is I'm going to plot the y-intercept on the y-axis. So the y-intercept is where the line crosses the y-axis. So if I go up to 5, there's the point for the y-intercept. And then I have to use the rise and the run of the slope. So remember that slope is equal to rise over run. In this case, we've got -2 over 3. So I'm going to rise, so I need to go to that starting point, the y-intercept, and I need to rise -2, so that means go down 2, and then run +3. So that takes me to that point there. And that pattern continues, so I can continue from each point going down 2, over 3, down 2, over 3, and it goes up the same way too, over 3, up 2, over 3, up 2. Now, it's not crucial that we plot every one of those points. Probably a good idea to plot 3 points there, because then you just need to draw the line through the points. And it's not crucial that we have every point there. 3 points is good. If those 3 points all line up nicely, then you know you're kind of on the right track. Arrowheads on the end, and then we write the equation of our line. So that's how we use the slope and the y-intercept to graph lines. All right, now we're going to talk about intercepts. So the x-intercept, first off, is when a line or a curve crosses the x-axis, okay? And anytime a point crosses the x-axis, that point's going to have a y value of 0. Okay? When we're talking about the y-intercept, we're crossing the y-axis, and any point on the y-axis is going to have an x value of 0. Okay? So we're going to do that for... so actually, I'm just going to draw a line on this graph. It really doesn't matter where the line goes. Let's say we've got that line there. Okay? So this is the x-intercept. And this point is the y-intercept. So if we can find those 2 points, we can plot those 2 points, and then go ahead and graph the line through those points. So let's do an example here. Here we've got an equation, 3x plus 4y minus 12 equals 0. I'm going to find the x-intercept first. So when we're talking about the x-intercept, I have to let y equal 0. So that means I'm going to substitute 0 in where the y is into my equation up here. And the great thing about substituting in 0 is that 4 times 0 is just going to be 0. So I end up with 3x minus 12 equals 0. I'll move that minus 12 to the other side, and it will become plus 12. Then I'm going to divide both sides by 3, and I end up with x equals 4. So that means the coordinates of the x-intercept are 4, 0. Okay? And now we're going to do the y-intercept. So for the y-intercept, we're going to let x equal 0. So same equation, but this time we're putting 0 in for the x. 3 times 0 is going to be 0, so we have 4y minus 12 equals 0. We move the minus 12 to the other side. It's going to become plus 12. And then we will divide both sides by 4, and we get y equals 3. So that means that the y-intercept is 0, 3. So we've got our x-intercept. We've got our y-intercept. We're going to plot those on the graph down below here. So the x-intercept, I'm going to plot on the x-axis. That's the point 4, 0. And 0, 3 is on the y-axis. And now we can draw the line through those 2 points. Okay, so that is what we're going to look like for that line, and I can write the equation of that line on there as well. So that's how we use the intercepts to graph a line. So we're going to do a number of examples here. We won't do all of them here. We'll save a couple for the warm-up tomorrow. But to start with, we've got y equals 3x minus 4. These first three, we're going to use y equals mx plus b to help graph them. So I think we'll do A and B here. So in A, our m is equal to 3, and our b is equal to negative 4. So remember to graph it, we start with the y-intercept, so I'm going to go to negative 4 on the y-axis. That's going to give me that point there. And now I need to count the rise and the run. Now before I had a fraction for the slope, this time I just have the number 3. So it's important that we remember that underneath that 3 there's actually a 1 there. And we don't usually write it there, but in this case we need to remember it because it represents the run in this case. So from that y-intercept that I've plotted, I rise 3 to get to here, and then I run 1. So that's going to give me that point there. I can draw my line through these points. Okay, so it's going to look like that. And we can put our arrowheads on the end, and we'll label that y equals 3x minus 4. All right, the next one. My slope is negative 1/4. My y-intercept is 2. So I'll start with my y-intercept. I'll go to 2 on the y-axis. And then from there, the rise is negative 1, so I'm going to go down 1. And then over 4 to the right. 1, 2, 3, 4. And there's my point. I'll draw my line. Let me just straighten that out. It's important that we draw these through the center of the points so that it's as accurate as possible. Let me just see here. I want to try and be as accurate as possible. That's going down 1. Is that not going? Are you cooperating here for me? Okay. That's pretty good. So I'll put my arrowheads on the end of that one, and I'll label that line. So it's y equals negative 1/4 x plus 2. I'm going to need C. We'll make that part of the warm-up. I'm going to come down and do D and E. So with D and E, I'm going to use the x-intercept and the y-intercept. So if I do the x-intercept here first, I'm going to let y equal 0. If I let y equal 0, I'm going to get x plus 0 equals 5. So that means x is equal to 5. So my x-intercept is going to be 5, 0. If I do the y-intercept now, I let x equal 0. So that's going to be 0 plus y equals 5. That one's going to end up being 5 as well. So my y-intercept is 0, 5. So if I'm going to plot these points on this bottom graph, my x-intercept is at 5, 0. My y-intercept is at 0, 5. So there are my 2 points that I will draw my line through. Okay, here's that one. Write my equation, x plus y equals 5 is going to look like that. And then in E, x-intercept, let y equals 0. So it's going to be 2x minus 4 times 0 minus 12 equals 0. 2x minus 12 equals 0. And then we want to solve that for x. So 2x equals 12. We'll divide both sides by 2. So we end up with x equals 6. So that means our x-intercept is going to be the point 60. And now for our y-intercept, we'll let x equals 0. So it'll be 2 times 0, and then the rest. So this time it's negative 4y minus 12 equals 0. Move the minus 12 over. We'll divide both sides by negative 4, and we get y equals negative 3. So that means the y-intercept will be the point 0, negative 3. So I'll plot those points in the graph. 6, 0 for my x-intercept. It's going to be right there. And 0, negative 3 on the y-intercept will go right there. And then we'll draw our line through those 2 points. We'll just extend it. Remember when we draw these lines, we want to fill the graph. And we'll label it. So this is 2x minus 4y minus 12 equals 0. Okay, great. So we'll do those other 2 questions with the warm-up tomorrow, and then we'll do some practice on that. Thanks.